This is Structure Analyze and Modeling Portal section Introduction to GSA. The first part of the tutorial has gone through the main window here, the top two bars, including the cases and the display. And the second part of this tutorial will talk about the left-hand toolbars and the right-hand toolbars. And we'll use the example to illustrate the function of these tools. So first of all, we will start from introducing the orientation toolbars. First will be the regenerate graphic view. This one is usually used if we have, for example, shows the bending moment, and right now it's pretty obvious, and it says that the data scaling is unreliable at the upper right corner, so we need to regenerate them. So that's how the software defined it as properly. Scale the diagram. Okay. Then the next will be the plan view. You can have a look at it. That will be the plan view of the model, followed by the x elevation, which is the elevation of y-o-z plane and equal to the direction of the lab view in the AutoCAD. And the y elevation here is the elevation of x-o-z plane equal to the direction of the main view in AutoCAD. Here will be the isotropic view, which is equal to the direction of the southwest isotropic in AutoCAD. And this part will be the skew view, also an isotropic view equal to the direction of southeast isotropic in AutoCAD. This one, that will be the ground view. Ground view. So it's actually a point perspective, like when you see here and you look at the whole model. And this one is scale to fit. For example, when you zoom out the model, make it so small, and click on here, scale to fit, it will show the entire model to fit in the graphic view. And if you zoom in, and you can't see the whole model, you can click on here, it will also show scale the model to fit in the graphic view completely. Then is the cursor mode toolbar, which is this one. Start from the beginning, there will be the rotate. Okay. Then we use the rotate to see different directions, different part of the structure. And if we use the next one, which is the zoom. For example, if I want to have a look at here, I can zoom in like that, or I can just select it, and it directly zoom into here. This one will be the volume. I use volume to show part of the structure. For example, if I just want to show this story, the top one, I just use volume to select it, and you see I only see that. It's pretty convenient and pretty useful, especially when you are constructing a very massive structure and you want to change only one part of the area. So you can also right click and delete the last volume. You can see that what it is before you delete it, before the volume actions. And this one, there will be omit from display, and to do that we need to turn on the section display on the right hand toolbar. So you can see that actually there are at least two different kinds of materials used in this model. One is steel, the other is concrete. And if I don't want to see any steel here, any steel in this display, and what I should do is select or click on Omit from display and just select any of the steel members. No matter it's a beam, it's a columns, and when it's selected, yeah, it will be omit from the display. So yeah, and it only left the concrete part. Okay, and we can see. We use volume 2 to select what we just see this before. And this one is used to select nodes. You can only use this tool to select nodes. And you can't use this tool to select element, which is like beam, column. If you want to select them, you need to use select element and member, for example, like that or that. But if you use this tool, you can't select the nodes. Okay. The polyline won't covered in this series, but you are recommended to go over its function via the help document in GSA. Here is select for ornamentation. This one is to show the figure of the diagram. For example, if I put out the bending moment diagram and I want to see the value of the bending here, so I can use these tools. I select for ornamentation and select this beam, and I can see that in the middle span that will be negative 37.77 kilonewton meter. So at the as well as the values at two ends. Here the last one, that will be the scalp toolbars, which is open and close the scalp toolbar. Okay, in the scalp toolbars, generally the function of it is used when you are designing a model. So since this model has been analyzed, you see here, it shows in gray, means that it has been analyzed. I can't change it. So we can go back to the model we defined earlier to show us the functions. So the first three tools are related to the grades, and we don't need to use grade in all the sections in this series, so we won't cover it. However, if you already have drawings in AutoCAD, and you also have the grade net, it can be a pretty good idea to use these functions, use these tools to help you to do the model in the GSA. The next one will be add nodes scalp tool, but that's based on the fact that you already have grade, and since we don't have, so it won't be covered here. And this one will be modified node scalp tool. So we go to the data defaults. We go to nodes. You see that in the data defaults, there's no restraint here. In X, in Y, in Z, in this XX, YY, ZZ, there's no restraint. So if I open the label the restraints of each node, and I change the data default of nodes to restraint X, restraint Y, and use these two. Right now it doesn't restrict anything, so it doesn't show anything at this node. But if I do that, so it suggests that I restrict the X and Y direction of this node, which is the same as the data default set. If I also restrain Z and don't restrain Y, and I select this node, it shows XZ, and select this one, you also change from XY to XZ. This functions is quite useful when you want to select several nodes or many nodes and change their constraint condition. This tool is drag node scalp tool. Sometimes when you want to, for example, looks like that, you want to combine two nodes together, you can do things like that. Or you want to change the location of these nodes and the other elements which is linked to this node will also go as where it goes. But you should be careful of using these two, because if sometimes you end up like the model looks like that, which is make no sense. And this one is the add elements scalp tool. This is one of the most commonly used tools in the GSA because we use this one to define elements. So we first click on one node, which is the first end of this element, and we go to the second node and click it, and we will generate a new element. This one is modify the element scalp tool. For example, if the element is defined here as property of 4, and I select here, and we can see at object view, not very clear, but okay, we can have a look at here. We right click, select this element, modify selected elements. Oh, because we haven't defined any property yet, so we can't see it, but it have the same function as in this tool, which is modify not scalp tool. If we have already defined several properties of the beams, and we can use this function to easily change the one or several elements to the precise properties we want. This is create user access, but not commonly used. Here is modify selections, as I just showed. If you can either right click, modify select element, or you can just use here. The command, there's also a shortcut at the command toolbars, or you can just click the modify selection at the scalp toolbar, and you will see, yeah, the same thing here. The move or copy selection is used when you need to copy something or move something. For example, if I want to copy these columns and make it to move 4 meters in X direction. So the most traditional way is go to menu, scalp, and click on copy. I want to copy it by 4 meters. And I can preview it. See, there is a new column here. So I can also do that in here. I just click on here, and same thing, I just set 4, preview. So I have a column here, which is 4 meters between these two. The next one is add string of 1D element. This element is actually quite cool. For example, when the most common way to define an element is by this one, using the add element scalp tool, as I just showed. But you can also select 2 nodes that you want to link the element, and just click add string of 1D element, and you just add 1. Quite easier than using this tool to click on one node and link to the other nodes. And this one that will, sometimes if we want to split the beam into different parts, for example, I want to add 2 columns between these 2 beams, so I can select them, and I can go to scalp, 1D element operations, split 1D element, and split it into 3 parts. Can preview, or it's not very obvious, but we can open the nodes. So right now you see the beams, each beam is divided into 3 equal parts. So I can also do that in here at the split 1D element /lines at the scalp toolbar. It's the same thing, and I split it into 3 parts. Yeah. Okay. So next we will go to the right hand toolbar, Start from the display favorite toolbar, which is this one. First will be the label not dot. The reason for that, as I just shown, if we have split these columns, these two beams into 3 equal parts, and if we don't select that, we won't see it. We don't know that it actually has been split into 3 parts. So open this one, you can see where the knot is. The knots are here, 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 and each knot, as introduced before, have a unique number. So to see that, you need to open the label knot numbers here. Here is the label the restraints as just introduced. So here you see that here has been restrained, here has been restrained. It will show the restraint condition. If it doesn't show anything, it's the default. And here can label the element number, since each element has its own unique number like the knots. Here labels the element's x-axis, which is the way how you link these elements. For example, if I add a new element from here to here to here, so you see the arrow is pointed from this end to this end. Okay, and the rest will show in here in this other GSA file. If we want to have a look at the load diagram, we can click on load diagram and we can see how the loads are applied. It's very complicated in this one, right? So yeah. And if you want to see the displacement diagram, we also mark how the building is, how the structure is deformed. So we can use select for illumination tool and select it to see actually how much millimeter the beam deformed. Here it shows the reaction diagram. Generally, if you encast something, you can see the reactions. So we can have a look, which is at the bottom part. Restraint at the bottom part, so you see here there's restraint, and you can see the loads, the reactions here is 320.6 kilonewton. And let's go back to the 3 floors we were looking at. So here is the Fx axial force diagram. It shows the axial force of the columns, or sometimes the beams. So if you want to have a look at the numbers, you can use the select for illuminations and see the values. So that these columns at the top part is undertook 5,429 kilonewton, at the bottom is 5,491. The next will be the shear force. It shows the shear force of each element. And it's the bending moment. After that, we will go to this toolbar, which is the graphic display. Sometimes it's not easy job to rearrange them. Okay, so let's go back to here. So if I label the knots here, we know that there are 2 knots here and 2 knots here. There's another way to identify that, which is using the shrink. So for each element at both ends of it, when you use the shrink, it will shrink a distance. It will shrink a part of the length and shows that here, okay, there's a knot here, there's a knot here. And this one is the section display. You can see in the example file. So it can display the section. How it looks like, what's the size of it, like these things. And sometimes you need to use this section display to visual check whether you have built the right thing or not. Sometimes you may choose the wrong material or the wrong cross-section size of the columns. And you can't see that from these lines. This one is labels and display method. We will use this function later in one of the sections when introducing the rigid constraints. And here is the deformed image. If we press that, we can see that the gray dashed line is what the structure used to be like, and the thick line, the green thick line, is the deformed shape under this locase. So when I change the locase, actually it changed the deformation and the both its shape and the value. This one is animate. It's generally used during the dynamic analysis of the structure. Since we don't have dynamic analysis in this model, so actually it won't show anything but just like that. But if you have conduct dynamic analysis, you can see how the building will vibrate at different modes. Okay, so let's turn it back. The next one will be the shade surface. Actually, this function is not very useful. You can open the section display and have a look. It will just look like that. It will color the shade. On counter setting, here you can see things, for example, like the displacement of the beams, the minimum of the beams. We close the section display, so you can have a pretty good idea according to the colors, and here to know to know the deformation of, like, for example, this column or these beams and this beam, or this column. Or you can also use select for ornamentation and select the beam, and you can see the deformation value here. If you don't want to see anything else, you can just press the reset displays and click yes. Here is the diagram settings, but generally you don't need to change anything here. The last three things here will be rescale data, double size of diagram, and half size of diagram. Rescale data is a bit similar to what you use by using the regenerate graphic view. For example, sometimes if I don't think it's clear enough of this shear force diagram, I can use this double size of diagram to increase them. And sometimes I think it's too large, I can use half size of diagram to decrease them. But if I want to see how the program thing is the best scale to represent this shear force, I will click on rescale data, and that's how it looks like, how the program consider it will be a good scale factor on this global scale factor. The last one here will be the recorder toolbar, so we can open and close it here. And this will be all for the second part of this tutorial. In the third part of the tutorial, we'll talk about the gateway menu and the bottom part, the bottom two bars, including the shortcuts and the object viewer.